Motion under a central force. Motion under a central force. Motion under a central force. In the previous chapter, we have seen how Galileo, understanding of inertia, led Newton's formulates his three laws of motion, which gives qualitative and quantitative measure of force, different types of forces which actually arises in nature, and also of those types of forces which cannot be explained by Newton's law. Basically, there are four fundamental types of forces depending upon the interaction of matter. These gravitational force due to gravitational interaction. Second, electromagnetic force due to electromagnetic interaction. And third is strong interaction, and fourth is weak interaction. The latter two forces are the short range forces of the order of the size of the nucleus is that 10 to the power minus 13 centimeter. Gravitational force is a long range force, also electrostatic force, and the interaction is the weakest. Still, it holds the earth together with the sun at its center in our solar system. Several stars like sun in a galaxy, several galaxies in a Milky Way, and so on in the universe. All the celestial bodies in the universe are bound by the gravitational force. Gravitational force is a conservative force and is an example of a central force. The first systematic study was made by Ptolemy in 100 AD on the assumption of a geocentric universe. Geocentric universe is that everybody in the universe revolves around the earth. This idea was discarded in 1543 AD by Nicholas Copernicus, suggesting a heliocentric universe. Body example is that bodies in the universe revolves around the sun, to which Galileo and Bruno supported in 1569. Tycho Brahe made careful observation of heavenly bodies for 30 years but failed to formulate. Kepler, who was assistant to Tycho Brahe, carried out the work and proved the correctness of heliocentric theory. He established three important laws about planetary motion around the sun. Central force. First heading of this chapter is central force. A central force is that force which is always directed away or towards a fixed center, and the magnitude of which is a function only of the distance from the center taken as origin. That means a central force is that force which is always directed away, which is always directed away, or towards a fixed, center, and towards center, and the magnitude of which and the magnitude of which, magnitude of which, and the magnitude of which, and the magnitude of which is a function only of the, which is the function, is the function, which is the function only of the distance from the center, distance from the center, distance from the center taken as origin, taken as origin, taken as origin, taken as origin. A central force is that force which is always directed away or towards a fixed center, and the magnitude of which is the function only of the distance from the center taken as origin, from the center taken as origin. In spherical polar coordinates, we express the center force as F vector r center force equal to F r unit vector r, where is a unit vector along r, where is a unit vector along vector r, and force r is a function of central force F r is a function of r, function of r. Characteristics. First number. The characteristics of central force between two bodies are: first number, the magnitude of the force depend only, the magnitude of the force, the magnitude of the force depends only on the distance, depends only on the distance between the centers of the two bodies. Second number, it acts along the line joining. Second number, it acts along the line joining, along the line joining the center of the two bodies, the center of the two bodies of these two bodies, center of the two bodies. And the third number, a central force is a conservative force. A central force is a conservative force. Conservative force. A central force is a conservative force, is that it is the gradient of some scalar potential. Is that it is the gradient of some. It is the gradient of some. It is the gradient of some scalar potential U r vector F equal to minus grade U or minus delta U, vector delta U. Examples, some examples. Some examples. Examples. Familiar examples of central force are: first number, gravitational force. First number, gravitational force of attraction between two masses. Gravitational force of attraction between two masses. Gravitational forces of attraction between two masses. If M1 and M2 are the two isolated masses at a distance r apart, then M1 and M2 are the two masses. M1 and M2 are the two masses. M1 and M2 are the two masses, isolated masses at a distance r apart. Then the gravitational force of attraction and the masses M1, gravitational force of attraction and the mass M1 due to mass M2. Due to mass M2 is given by F12 vector F12 equal to minus G M1 M2 upon R square unit vector R equal to F vector R unit vector R, where Fr equal to minus Gm1 m2 upon R square equal to minus C by R square, and C equal to Gm1 m2. C equal to Gm1 m2. Second number is, if electrostatic force of attraction, electrostatic force of attraction or repulsion between two charges. If plus q1 and plus q2 are the two isolated point charges at a distance r. Q1, this is the q1 and this is the q2 charges aparted by r. If plus q1 and plus q2 are two isolated point charges at a distance r apart, then the electrostatic force of repulsion on the charge plus q1 due to the charge plus q2 due to the charge plus q2 in vacuum is given by F12. In vacuum is given by F12 vector equal to K q1 q2 by r square unit vector r equal to F r unit vector r, where Fr equal to K q1 q2 upon r square equal to plus C by r square, and C equal to K q1 q2 in SI units K equal to 1 upon 4 pi epsilon naught, where epsilon naught is the permittivity of free space, is the permittivity of free space, permittivity of free space, non-central force. Next is non-central force. Non-central force. Second number, non-central force. Non-central force. Non-central force. A non-central force is that force which does not simply depend upon the distance between the centers of the two interacting bodies, but also on other parameters such as their spin and relative orientation. A non-central force is that force. A non-central force is that force. A non-central force is that force. A non-central force is that force which does not simply depend upon, which does not simply depend upon, is not simply depend upon the distance between the centers, between the distance between the centers of two interacting bodies, two interacting bodies, but also on other parameters, such as their spin and relative orientation, such as their spin and relative orientation, characteristics. First number, they are a short range force. They are short range force. Is that the force act only when the interacting particles are very close to each other. Second number is non-central force do not necessarily act along the line joining the centers of the two bodies. Non-central forces do not necessarily non-central force do not necessarily act along the line joining the centers of the two bodies, and third number is a non-central force is non-conservative and cannot be derived from some scalar potential. A non-central force is a non-conservation. A non-central force is non-conservation or non-conservative. A central force is a non-conservative and cannot be derived from some scalar potential, and cannot be derived from some scalar potential, some scalar potential. They are not the gradient of some scalar functions. Example, familiar examples of non-central forces are examples. First number, weak forces. Familiar examples of non-central forces are called into play in beta decay and decay process. Called into play in beta decay. Called into play in beta decay. Play in beta decay process where the decay products are leptons. Process where the decay products are leptons. Electron, as an example, electrons, positrons, neutrons, and micromesons, etc. Micromesons, etc. are non-central. Weak forces are non-zero only when the interacting particles just overlap. Second number is strong nuclear forces. Strong nuclear forces between proton. Strong nuclear forces between proton interacting, proton neutron interacting, proton neutron interacting, and neutron interacting are non-central as these are due to the examples of pi positive, pi negative, and pi zero mesons respectively. Okay, thanking you. And next heading is conservative force.